When we follow the right scientific methodology, we'll get the right result. We will get the right research output. If we use poor methodology, if we follow poor methodology, the result also the same. So we have to use some standardized guideline to formulate our scientific research methodology. So in this video, as a first point of discussion, I will try to explain what are key elements expected to be included as a part of methodology for machine learning, the deep learning based. So as first step, we have to explain or mention our research design as first step. One of key components has to be included is our research design. We have to indicate the nature of our research, whether it is experimental, whether exploratory, descriptive, applied, different kind of research design is there. So we have to explain it clearly because it is our blueprint for conducting research. And the second, we have to mention our research approach. Which research approach is followed? Is it quantitative, qualitative, or both, including justification? The rationale for choosing particular approach expected to be mentioned well. The other important key element is data set source and also characteristics of data sets. So we have to mention the data set source. We have to indicate whether our data is reputable or reliable. Is it recent? Is it supported by domain experts, agreed upon by most of domain experts? So we have to mention where is our data is originated, because data is very important aspect for machine learning AI approach models. Data is a critical aspect because those models are data driven by data to make some decisions. So it is a critical component. So reputability of data is a very important aspect. So we have to carefully choose the right source. The other one, we have to explain the characteristics of data set by itself. What is characteristics of data set? We have to mention how many number of instances included, how many number of features included, and also how is data set distribution, class distribution of those data sets. Is it normally distributed or imbalanced distribution is there? So we have to explain those things in detail, and also we have to explain the format of our data set. Is it image? Is it number? Is it audio? Is it video? There are different multimedia data sets are there. Different data is represented in different formats. So we have to explain the nature of our data set, whether it is categorical or non-categorical. So different things are there. Data set source and characteristics has to be explained very well. Another very important part is data pre-processing. Once we collected our data, we have to pre-process it carefully. So what we call data cleaning. In this data cleaning, we have to incorporate what techniques used, how we handle missing values, how missing values are handled, how outliers are addressed, inconsistencies, redundancies in a data set, how to remove redundancies, inconsistencies, and also how to address class imbalance issues. If we face class imbalance, what data set balancing strategy is used and why, including why, the rationale for choosing those strategies. The other one is data transformation. What techniques are used for standardizing or normalizing our data set, what we call feature scaling. How we handle the categorical variables. Is it manual approach or automated approach? We have to explain it. Another important component is, as a part of data pre-processing, is feature engineering. Under feature engineering, there are two key elements are there: feature extraction and the feature selection. Feature extraction means just generating new features from existing feature. We generate new feature from the existing one. For example, the technique we apply to do these things are like PTA, principal component analysis are used for data extraction. It is not feature selection technique. It is data extraction technique. From existing features, it extract new features, generate new features. So the difference between feature extraction and the feature selection is that in feature selection we generate new features from the existing features, while feature selection we choose relevant feature subsets from the dataset. Just many features are there in a dataset. We have to select the relevant one that have special meaning to the model accuracy and the speed. That is what we call feature selection techniques. So there are diverse feature selection techniques are there in the literature, like chi-square, ANOVA test, percent correlation coefficient, mutual information, recursive feature elimination. There are diverse feature selection techniques are there. They are classified into three: filter based, wrapper based, and also embedded based. In filter based, it is feature is selected independently of machine learning, the deep learning model, while wrapper based is it is incorporated on model interaction is there. For embedded also, it is built-in feature selection techniques are there. Some machine learning, the deep learning techniques having some built-in feature selection techniques. So we have to choose which feature selection technique is appropriate for a given data set. We have to make some comparative study to choose a better one for our selected problem. The other important point is how we split data sets. Train, test, validation data sets are there. The way we split our data sets affect the model output, which train, test, split ratios we use. So different data splitting techniques are there, like holdout cross validation and k-fold cross validation techniques are there. Which one is appropriate to avoid model overfitting issue also? So we have to compare different feature data split ratios. Is it 80-20, 70-30, 25-75 ratio, 60-40 ratio, 5-fold, 3-fold, 10-fold, different techniques are which one is appropriate for a given data set. So we have to conduct rigorous experiments to choose the better one. Because we have to careful, because how much data size is given for training, how much data size is given for testing. So the data set we used for testing we can't use for training, because once we trained our model we have to test it with the new data set. So the proportion of training test split ratio should have a great impact on model performance. So data set split ratio also there. The other important part, model selection criteria. The rationale for selecting particular machine learning and the deep learning algorithms. There are diverse myriad of machine learning and the deep learning algorithms in the literature. So machine learning model appropriate for suitable for one problem may not be suitable for another problem. Machine learning model top performed on one dataset may not perform on another dataset. So we have to mention the rationale for selecting particular machine learning or deep learning algorithm. First, we have to understand the nature of datasets. It is the nature of datasets that determine what type of machine learning algorithm we choose, because different classes of machine learning are there: supervised, unsupervised, semi-supervised, and the reinforcement also there. So if we have labeled datasets, if we need data classification and the prediction, we may apply supervised technique. If you don't have labeled datasets, we may apply unsupervised techniques. And also reinforcement techniques also there, because model collecting real-time data to act upon the current activities. So it is the nature of data sets we have help us to select what type of machine learning and the deep learning techniques are there, because there are the problems that need time series data. If it is time series seasonal data is there, which deep learning algorithm is appropriate for seasonal time series data application. So we have to rigorously analyze intrinsic property of each machine learning and deep learning algorithm. So we have to measure the rationale for that. The other one, we have to choose what optimization technique is there. We have to measure model optimization techniques. Some optimization techniques are built-in optimization techniques are there. For example, for deep learning, we have Adam optimizer, stochastic gradient descent, different intrinsic optimization techniques are there. There are also optimization techniques external to machine learning and the deep learning algorithms. Like we can apply genetic algorithm, BAT algorithms, different optimization algorithms are there. Different optimization algorithms are there. So we have to make comparative analysis, to choose which one is appropriate for our given data set. So this is also there. The other important component is regularization technique. The major challenge we face while training machine learning and the deep learning model is that model overfitting issue. Model overfitting issue is commonly experienced by machine learning based researchers because the model accuracy, training accuracy increases while model testing accuracy is decreasing. So in that case, we call it overfitting. Model overfitting. So to handle those model overfitting, we apply different techniques like dropout, early stopping, different lasso techniques are there. So model training accuracy and the testing accuracy has to be balanced. So to address how we address model overfitting issue also another important component. So we have to explain it as a methodology part. The other important aspect is model hyperparameter tuning techniques. How to fine tune our models. So machine learning, the deep learning algorithms have their own default parameters. Built-in default parameters are there. So fine-tuning model parameter will give us a better result. We have to change those parameters to get better result, because those parameters are depend on how much data size we have, the nature of data size we have. Is it small, medium, or large? So based on that, we have to fine-tune our model to get better results. But while fine-tuning our model, careful consideration is very important. We have to carefully select appropriate model parameters, because when you increase model parameters, we may add some complexity to the model in terms of model computational time. Resources that consumed, computational cost, computational time will be added if you increase the number of parameters used for fine-tuning the model. So different techniques are there for fine-tuning a model, like research, Optuna, random search, binomial. Different statistical techniques are there for choosing appropriate parameters for a model to get better results. So while selecting model hyperparameter tuning, we have to balance between accuracy and also model computational time. Computational cost also very important. The other important element is which model evaluation metrics we use. What are different model evaluation metrics are there. So the model evaluation metrics we use for classification, detection, and the classification is different from the model evaluation metrics we use for prediction. So when you use where our problem is its classification, we may use accuracy, F1 score, precision, recall, Matos correlation coefficient, different model evaluation metrics are there. However, when we use our problem is our prediction, there are different statistical techniques are there for evaluating our model, like root to mean squared error, mean absolute error, R squared. Different techniques are there when our focus is for prediction. So we have to differentiate that which model evaluation metrics you used for which type of problem, because machine learning can be, deep learning can be used for classification and the prediction, used for clustering, used for association. So which problem we are trying to solve determines the model evaluation matrix we choose also. Another important component expected to be included is experimental setup, where the environment that we conducted our experiment, what parameters we use to conduct experiment. We have to mention computational resources we use. If you conducted experiment on our laptop, we have to write specification of our laptop, how much RAM, how much hard disk, how much specification should be there. When you conduct experiment on a server, also we have to indicate what resource, how much hard disk, processor, different things has to be mentioned, because experiment done on our laptop and on a server may not have the same performance, because when you conduct our experiment on a server, it is fast, it is so fast, so when we conduct on our laptop it may be slow. So we have to mention those specifications. What software tools are there, tool selection criteria. There are different tools are available for conducting the research. So we have to mention the rationale for choosing particular tools, research tools, among others, because alternative tools, there are tools used for the same purpose, but we have to mention the rationale for selecting a particular tools. So we have to explain each important parameter used for this research. So mentioning these key elements is important for while to write proposal, and also while we are writing manuscript to submit for publication. These important components are expected. Reviewer also suggests this component, looking at whether these components are available or not. So otherwise they will ask you to incorporate it. So before that we have to focus on this guideline. We have to mention research design, research approach, dataset source and the characteristics of dataset, data pre-processing techniques used, feature engineering, data splitting, model selection criteria, optimization, type of optimization algorithm used, regularization techniques, hyperparameter tuning techniques, type of model evaluation metrics used, and also experimental setup. So we have to focus on these important elements. So some additional components are there, but the aforementioned components are mandatory, especially for machine learning and deep learning based research. Another important point I explain for you is what are open issues in artificial intelligence and in general in machine learning and deep learning based research. So the first open issue is explainability issue. The open issues in machine learning and deep learning based thing is explainability issue. The model can't tell us how the current decision is made, how and why the current decision is made. So the model may achieve 99% accuracy, but why is the missing accuracy? Why 1% is missed? There is no explanation. Our model may achieve 80% accuracy. Why 20% accuracy is left? We don't know. It is like black box. So what makes it different from human is this thing. For example, if I made some exam correction for students, student may score 20 out of 30. So why this x is you give me this x? If a student asked me like that, I can explain for him. You didn't mention this point. That's why you get 20 out of 30. If it is human, it will explain like this. If it is artificial intelligence, machine learning, deep learning, no such things are there. So whatever problem you are addressing using machine learning or deep learning, you have to add, you expect to add explainability issue to build trust. To what extent the model is trusted. So to increase trust on a model, please consider explainability issue while for your problem, for your model. This is open issue. The other open issue is adversarial attacks. For example, you developed a model to detect and prevent cyber attack. You used AI approach to do that, to detect and prevent cyber attack. Attacker also can use AI techniques to bypass this model. We both are using the same technique. Attacker also use artificial intelligence. I am also used artificial intelligence for preventing those attacks. So we have to check whether our current model, the developed model, is vulnerable to such attack or not. So adversarial attack, preventing adversarial attack, also one of hot issues, current hot issues, open area. The first one is explainability. The second one is how to prevent adversarial attack, also another important point. Another open issue is that about train test split ratio, selecting particular train test split ratio. There is no scientific evidence to select particular train test split ratio. We select train test split ratios through trial and error. So we have to do something for how much data set is. For this amount of data sets, this train test split ratio is appropriate. So we have to conduct a research towards that thing. How to select particular train test split ratio. Which train test split ratio is appropriate for small data set, medium data set, and the large data set. And also, what is the maximum and the minimum threshold to say a small data set, medium data set, or large data set? What is the minimum threshold or maximum threshold? This is we don't get these points in the literature. So we have to have some common ground. You may train your model using 10,000 data sets. Somebody may say that you use the small data sets like that. You use this very small data sets. Somebody may tell you like that. But we don't know the threshold, is cutting point to say it is a small data set, it is medium data set, or large data set. So we have to conduct experiment on different data sets to decide this is a small data set, this is medium, or so. These are open issues. So the other open issue is that most researchers are focusing on enhancing accuracy of their model, but they are overlooking how much is model computational time. Because considering model computational time is one of important aspects, because our model is maybe accurate, 99.9% accurate, but when we implement it in a resource constrained device, like in developing country like Ethiopia, those our resources, our mobile devices, our laptop can't afford those resources, the developed model, if it's created with some applications. So we have to focus on how is the computational time of our model to say that our model is effective and efficient. So thank you for watching. If you are new to my YouTube channel, please subscribe to follow my upcoming videos. Have a nice day. See you next time.